Hello, friends. Now we're going to talk some more about functions of several variables, and we're going to take the chain rule and apply it to functions of several variables. Now, let's recall the chain rule that we learned in Calc 1. So if we have w being some function of x, and x then being some function of t, well, then we would be dealing with a composition situation where w is some function of g of t, right? And the derivative of a composite function, in order to find that, we're going to need to use the chain rule. So if we wanted to find the derivative of w with respect to t, well, w is a function of x, so that derivative would be dw dx, then times x being a function of t, we would have dx dt, right? Derivative of the outside times the derivative of the inside. And we end up with kind of what we call a dependency diagram. It shouldn't have an arrow at the end. So w being some function of x, we have this x, and x turns into a t. So along the way, we said derivative of w with respect to x, and then times derivative of x with respect to t. All right, so we have a dependent variable, which is w. W depends on what x and t are. X is what we would call our intermediate variable. And then we have our independent variable, t, over here at the end. So we're going to think about this definition as we create, develop, understand the definition for the chain rule in functions of several variables. So bringing that definition I originally had back on the screen in here, we've got w, a function of two variables, x and y. X is a function of t, y is a function of t. So if these are all differentiable, and we know that composition, x is x of t, y is y of t, the composition will also be differentiable. So the derivative of w with respect to t, and this is a little cramped, is the partial with respect to x times the derivative of x with respect to t plus the partial of that multivariable function with respect to y times the derivative of y. Or rather, partial of f with respect to x, derivative of x with respect to t, partial of the function with respect to y, and the derivative of y with respect to t. We could go so far as to write it with some other notation. We could say dw dt. Instead of f, we could write partial w with respect to x, dx dt, plus partial w with respect to y, dy dt. So these three notations, they all mean the same thing. Let's think about our dependency diagram for the chain rule with functions of several variables. So I've pulled this image in here. Let me actually slide that up a little further so we can see it all on one page. So we're going to start with w. W is a function of x and y. Now, x is a function of t and y is a function of t. So x here, that's the same as saying x of t, and the y is some y function of t. So we take the partial of w with respect to x and the partial of w with respect to y. That gets me to my intermediate variables. And once I'm at my intermediate variables, we're going to differentiate x with respect to t and differentiate y with respect to t. And so that's just kind of a method to help us remember our chain rule for functions of several variables. Okay, so in this section, we're going to talk about, more than two independent variables. Maybe situations where we have three independent variables. And those rules look very similar. There's some more levels to it, if you will. So now that we have talked about this, let's do an example. In this example, we're going to find the derivative of a composite function, function of more than one variable. We've got x and y. X and y are both functions of t. We've got cosine t and sine t for y. So we're going to use the chain rule to find this derivative of w with respect to t along the path of x, cosine t, and y, sine t. So these are both functions of t's. And we're going to determine the derivative value at the given t. T that is given is pi over 2. So in order to do this, we will apply the chain rule. And so we know our chain rule. The derivative of w with respect to t is the partial of w with respect to x times the derivative of x with respect to t plus the partial of w with respect to y times the derivative of y with respect to t. How do we know that? We just learned the formula on the previous page. All right, so partial of w with respect to x. Partial with respect to x of w equals x, y. That means we treat y as a constant. So y is like a coefficient in front of x. So in that situation, we're going to end up with y. The partial with respect to y of that same function, w equals xy. So partial with respect to y, treat x as a constant. That's a constant coefficient. We're going to get that this value is just x. All right. Derivative with respect to t of x equals cosine t. Dx dt, the derivative of cosine, is negative sine of t. And lastly, I'm running out of space, I'll cram this in over here. The derivative with respect to t of y equals the sine of t. So that gives me, I prefer to write that below, dy dt, derivative of sine, is cosine of t. So I now know my dy dt value and my dx dt value. Since we found all of those, we can write this out. The derivative of w with respect to t is y times negative sine of t plus x times cosine of t. So pause the video, make sure this makes sense to you, how I found these four pieces that I've included here. So now let's talk about simplifying this. So I'm going to rewrite this. This is dw dt, I'm going to say x cosine t minus y sine of t. All right, so we're almost done, but this is w as a function of t, or the derivative of w as a function of t, which means this x and this y need to go away. So we go back up to what was originally established or given. X is cosine t, y is sine of t. So the derivative of w with respect to t is cosine t times cosine t minus sine t times sine t, plugging those in for x and y. dw dt, that is cosine squared t minus sine squared t. And we can simplify this one step further because I know you all are immediately recognizing the trig identity that's displayed, and that's our cosine double angle. So that is the derivative. Now, what is the derivative at t equals pi over 2, part B of this question in a sense? dw dt evaluated where t is equal to pi over 2. We are evaluating cosine 2t. So that is cosine of 2 times pi over 2, or rather just cosine of pi, and cosine of pi is -1. So we found the derivative of a function of two variables using the chain rule, and then we evaluated it at a given t value. So I'm going to stop that video for here, and we're going to talk about different examples and different quantities of variables in the future videos. But make sure you understand this before we move along. So this was the chain rule for a function of two variables, and each of those two variables being a function of t.